All right, so today we're looking at 12-1. This is writing and evaluating simple functions. All right, so we've gone through this before, so I'm going to go through it pretty quick. Remember, a function is something that has an input and an output. So I plug something in and I get something out. And of course, so when I substitute a 2 in, I get a 10 out. Okay? So I have an input is my x, the output is my y. Substitute a 3 in, I get a 15 out. A 4 in, I get a 20 out. I substitute, it doesn't matter, I substitute a 7 in. Can we predict what's coming out? 35. So what happens if I substitute it, just put an x in there? What will I get?
5x.
A 5x. I'll get a 5x, right? So the rule is y is equal to 5 times the x. Now, we can put this in table form. Oops. Okay, we can put that in table form, or sorry about that. I can also, put these in ordered pairs. These are ordered pairs. So it'd be like 2, 10, 3, 15. Okay? I'm writing with my finger, so you have to disregard. So these are functions. Now, we can also see functions in a different way. What is a relation is any set of ordered pairs with no particular pattern. And we said that the domain is the set of input values and the range is the set of output values. So when I have this here, who can state for me the domain? Tyler.
You add?
We don't add. What does that mean, the domain is the set of input values? Lizzie?
Wait, would it be 2, 3, 4, and 5?
Yeah, it's just our x values. The domain are our x values. So it's 2, 3, 4, and 5. The range is our set of output values. So what would that be, Gwen?
5, 7, 9, and 11.
That's right, 5, 7, 9, and 11. Okay. Now you guys do number 2. Find me the domain and the range. I'm really in trouble here. All right, so what is the hold on one second. Find my stylus. Oh, here it is.
I found it.
Did you say you found it? All right. God. Okay, so what is the range on this? Let's go with Emma.
The range is
Or let's go to the domain first.
-3, -2, -1, and 1.
Perfect. Okay, and so now we have our domain is, and our range, whoops, sorry I gave the answer. Let's go, Brenna.
10 and 6. Well, 10 and 6.
And we don't need to repeat it. It's just saying the only range values that are going to be are 10 and 6. Okay? All right, so now I'm continuing on. I'm going to skip this. Well, let's just look. What? I'm going to come back to this. Well, let's look at functions and word problems right now, and we're going to come back to this as well. But when we write a rule for a word problem, the domain is our input value. It's what we plug in. And the range is what we get out. So if Logan assembles outdoor barbecues at $8 each, write the rule that represents his pay Y in terms of X. The pay is Y in terms of X, number of barbecues. So we're going to call our domain what? X, or what does it stand for? Number of barbecues. Okay, and our range will be our Y, or our cost, or our what we get paid. Okay, and so what would the equation be? What would the rule be, the function rule be? Based on this information, Y equals what? Anybody? Y equals X? Make sense of the word problem, people. Y equals 8 what?
Y equals 8x.
8x. Okay? Where 8 is our constant. It's like it's our slope, but that's what's always going to be, because if I make 2 barbecues, I'm still getting $8 a barbecue. If I make 3 barbecues, I still make $8 per barbecue. That's constant. And so all I have to do is multiply the number of barbecues by 8, and we'll get what I make. So if I make a few barbecues, will I make a lot of money or a little? A few. So if I make a lot of barbecues, I'll make a lot of money.
A lot of money.
So now, being able to apply it. After you write it, they're going to give you, if he assembles 20 barbecues last week, what would he get paid? So we substitute that in for the X, and we get our amount that he gets paid. Is that making sense? Okay. So let's keep going. All right, so that's the idea of writing the equations in, okay. Another way we see functions, we can tell from an X and Y chart. Another way we see it is in a map. We call this mapping. Okay? Now, what this means is that this is an ordered pair. 2, -4. -1, -2. Does that make sense? Okay, so the rule for a function is there can be no what? Who remembers? No repeated x's. Are there any x's repeated here? No. So this, in fact, is a function. Now, this is the same function as this. This is in mapping form, and this is just in T-chart form. Okay? Now, let's take a look at another one. Remember, a relation is any set of ordered pairs. So when I get something like this, okay, I have the same thing. I'm going to do my mapping. And I draw an arrow to every mate. So 1 goes with 6, 2 goes with 7, and 3 goes with what?
7.
Also with 7. Is this a function?
Yes.
One person says yes, one says no. What's the rule to be a function?
No repeating X's.
No repeated x values. Are there any repeated x values?
No.
So this is in fact a function. Okay, here's another one. And let's look at the map. Okay, so what this means is when you get it in mapping form, write the ordered pairs. 1, 6. What's the next one? And what's the next one? Okay, are there any repeated x values?
Yes.
Look how it looks in the map. I have 2 arrows coming out of the same number. When you have that, it's not a function. So you have to be able to identify it from the map, from the table, or from the graph. Okay, questions? All right, moving on. No, but it may be presented to you as a map, so you have to know how to read it. All right, with functions, is the second one a function?
Yes.
Yep, because there's no repeated x values. Is the third one a function?
No.
Because the ones repeat. Okay. Now from the graph, well, let's just do this. When x is -2, the y will be what? 2. When x is -1, the y will be 1. Is this a function? Yes, it is. Now look at this. When y is -2, the x will be +2. When x is -1, when 0, 0, 1. So is this a function? No, not when the absolute value is on the y. Okay, we can see it in the map. 2 arrows come out of the 1, and 2 arrows come out of the 2. So it's not a function. Remember, what is the rule for a graph? What is the rule for a graph? Who remembers to tell if it's a function or not? How can I tell if this, let's see if I have any right here. What'd you say? The vertical line test. Let me see if I have any right here. I don't think I do. So if I have a graph and it looks like this, is this a function?
Yes.
If I have a graph and it looks like this, is this a function? No, because it doesn't pass the vertical line test. It crosses the vertical line at 2 places at the same exact moment. Is this a function?
No.
Because it doesn't pass the vertical line test, it passes it 2 times at the same moment. Okay? What about a parabola?
Yes.
It is a function because it's not exactly vertical. Okay? Function notation. It's a fancy way to write y. So normally we write it, y equals 2x plus 3. This is the function of x. This is how we read it. Is equal to 2x plus 3. Well, you put your input in for the x. So when x is 1, and you just do the math for it. Okay? So the way they write it is like this. The function of 1, that means I have to plug in 1 for my x, is equal to 2 times 1 plus 3. There's no math you do for the f of 1. We just do the math on the right side. So it's 2 plus 3. What does that equal? 5. So we have the function of 1 is equal to 5. Well, what if they said, what is the f of 3? Well, you do the same thing. The f of 3 is equal to 2 times what? 3 plus 3. I don't do anything to the left side. It's the f of 3. equals 6 plus 3. So the f of 3 is equal to 9. The function of 3. Do you understand function notation?
Yes.
It's just a fancy way to write the y.
Why? Why are you?
Okay? Now, they're going to give you 3 numbers every time. Like, most of the time they'll give you, not every time, most of the time they'll give you more than one. What is the f of 1, the f of 2, and the f of 3 when you have this equation? So you're just going to do it 3 times. Now, sometimes they change it, and they'll say the g of x is equal to 2x. So in this case, notice they want the g of x. You have 2 equations up here. So which equation am I using that has the g in it? The g of x equals 2x. So I'm just doing 2 times 4. Does that make sense? And so the g of 4 is equal to 8. This time, what equation am I using for number 2? The h of negative 2 equals 4 times negative 2 plus 1. So the h of negative 2 equals negative 8 plus 1.
Why is it 2?
Okay, the h of negative 2 equals negative 7. Okay, what's your question?
How is it for number 1?
They're giving, number 1, they gave you the value of 4. They said, what is it for 4? In this, and when it shows you the g, it says use this equation. When it shows you the h, that means you have to use this equation. And they're giving you the value to use for the x. Okay, why don't you try number 3? Go. All right, so the g of negative 3. The g of negative 3 is what? Okay, what am I doing? What am, so I'm using the 2x, and so then I have the g of negative 3 is equal to 2 times negative 3, and we get g of negative 3 is equal to negative 6. Okay? You get the idea?
Would the answer be negative 6? Or
Yeah, just negative 6. That's basically like saying y is equal to negative 6. It's just called function notation. All right, now, let me just go through really quick. I think the rest I'm going to do out of the book. Just want to make sure. Oh, this one's a good one to do. So this is a typical one where they're going to give you 3 different problems. So they'll give you 3 different values. So basically, you're having to do all 3 times, just 3 different problems. The f of x is equal to 4 times negative 1. You with me? So the f of x equals negative 4. The next one is the f of x equals, I should put the negative. Okay, the f of, the first one was negative 1. Usually put the value in. So the next one is the f of 0 equals 4 times 0. So the f of 0 equals 0. The last one was the f of 2 is equal to 4 times 2. So the f of 2 equals 8. So inside, I can put it all into braces, negative 4, 0, and 8. Evaluate the function over the domain. So look at the directions. Do you see that? Sounds really fancy. Can you do it? Yes, it's not so hard. Find the value of the function knowing the domain. Okay? All right, can I erase? All right, so let's look at some word problems. So Now we're looking at some word problems. Let's look at it's not showing that. There we go. All right, let's look at some of these word problems out of the book. This is on page 540. 540. So the first thing they're saying is the cost of replacing a defective tire is a function whoops, of, sorry. Okay, the cost of replacing is a function, cost of replacing a defective tire is a function of the tread depth. The chart below shows, describes one such function. So, let's look at, I'm going to do 23. They said the cost is a function of tire depth. Okay? So look, find the cost of replacing a tire let's do this one, whose price is $78.50 and whose tread depth is 7 millimeters. So, what's the constant? We know that it's going to be $78.50 is the cost of the original tire. But it's down to 7 millimeters. So what am I going to use? 30% of that. So I'm multiplying it by. Okay. That's it. And then when I multiply that out, so I should have written it like this first. The cost is a function of tire depth. $78.50 times the tire depth. Okay? So the cost, what about at 30%? Right? Because that's what our 7 millimeter tire is charging, 30% of that. So I substitute it in, and we get $23.55. So the cost of 0 3/10 is equal to $23.55. Does that make sense? Okay. Now let's continue on. There's another one. Let's go down to number 26. The function r of t is equal to 33 1/3 t. So there's the original function notation equation. Now it says of 33 1/3 RPM as a function of t in the time minutes it is on a turntable. So RPMs is how many times it turns around. And it says find the number of revolutions at 5 minutes, 20 minutes, and 25 minutes. So I'm going to do the same thing. The R of 5 is 33 1/3 times 5. And we got to change this to an improper. The R of 5 is equal to 100/3 times 5. The R of 5 is equal to 500/3. And when we divide 500 divided by 3, we get 166. So for 5 minutes, it's 166.6 repeated, or we could say 2/3. Okay? Now, notice that problem. It says for 5 minutes. What do I have to do next for 20 minutes? Same thing. Only this time I'm putting a 20 here and here. And then evaluating 20 here and here. And then evaluating it and evaluating it. Does that make sense? And then we have to do it a third time for 25 minutes. So that's really 3 problems. So this is how we do function, write it in function notation. I'd love for you to I want you to try and do the word problems, but please try and write it in function notation. It will be easier for you in the end, even if the just so you're able to identify it when it comes to you on a CST. All right, are there any questions?